let's get going. What do you think about number 1? Loop-de-loo it, absolutely. And when we loop-de-loo it, we end up with 3 to the x equals 81. And we know that is 4. Now, kids, you're not going to have a calculator on this quiz, all right? There's no calculator on this quiz. When you, what, Emma?
Well, I thought I had a quiz, but it's both.
You need a practice quiz?
Yeah. Thank you.
Now, if you don't know that 3 to the 4th is 81, let's not guess. Let's start multiplying out 3's until we get to 81. Okay? All right, so 4 is the answer. All right, what about number 2? Very complicated looking problem. What do you think? We did several of these the other day. What do you think? What's special about 4 and 8? They're both powers of 2. Somebody said their base is 2. They're both powers of 2. So 4 is 2 squared. And 8 is 2 cubed. Right? Now, what do I do with these exponents right here? Multiply. So 2 to the 4x plus 6, that's a distribute, you're multiplying those, equals 2 to the 9x minus 3.
Yep.
Now, what does common sense say? If 2 to this power is the same as 2 to this power, then don't the powers have to equal? Emma, what you doing there? Just typing away? All right, so 5x equals 9 and x equals 9/5. Is that okay? Now, what if the problem, instead of having a 4 and an 8, what if it had a 9 and a 27? Then you would write them as powers of 3? Okay. All right, next. Oh, see, this is what we haven't talked about in a long time. This is what we really need to review. This is why we're doing 2 practice quizzes, because there's a lot of information. So your job is to take that big long thing and write it as the log of one quantity. So 1 logarithm, a single logarithm. So anybody remember how to do that? We haven't done this since before Thanksgiving. You remember how to put all this together, Tanner? What'd you say?
The log x, the log y equals the log xy. Put them together.
Okay, these are going to go together as a multiplication. But before you do that, what do you do with that? What happens to that number out in front? Where does he go? He becomes an exponent. So this is going to be the log of x squared times y, x squared times y, and then what about this? Divided by z. When I had you write down your properties of logarithms, or I asked you to, there are 3 of them. When we combine logarithms, additions become multiplications, subtractions become divisions, and coefficients become exponents. It works backwards too. So if we wanted to take this apart, it would work the same way. Multiplications become additions, divisions become subtractions, and exponents become coefficients. Okay, if that's bothering you, you might want to go back and look at that section of your notes. We did a lot of problems that way. We haven't done them for a long time. Okay, so make sure this becomes an exponent on the x, then put these together as a times, and that is a divide. You all right? Okay, simplify. Well, someone just asked a question about this. You knew this a couple of different ways, but if you remember what? ln and e right next to each other, touching each other. ln e always cancels. So what's the answer to the problem? 7x.
Is it the same with log? If it's a log and
Yep, log 10. Very good question, Emma. That's exactly right. If it's a log 10, those cancel each other because the base is 10. Yep. Good observation. Very good observation, Emma. We don't run into that very much, but boy, when we do, you can do that. All right, what about this? This goes all the way back to the beginning of the year. We need to get this right. Ava, what do you think? Where would you even start this?
move the negative to the bottom.
Okay. Ava, I think she's, you can start this lots of different ways, but I think Ava's so right. I like to simplify what's in here first. So she says, all right, look, the 3 and the 4, nothing cancels, it's done. What about the x's, Ava? I have an x squared over an x to the first. What's going to happen there?
X to the 3.
No, they're not being times, they're being divided. So think of it, Ava, as you have 2 x's on top of 1 x. Aren't these going to cancel?
Yeah.
And leave me with 1 on the top?
Yeah.
So when you have x's on the top and the bottom, they're going to cancel. And whoever has the most gets the leftovers. So there's 1 leftover here. And since that's a bigger number, that leftover's on the top. Am I making sense to you? Okay. Now, I got a negative y. So Ava says he's got to come down. So you're going to bring that y cubed down to the bottom. There's already 5 of them down there. So when you bring that other 3 down, now you're going to have y to the 8 on the bottom. And don't forget, we still have to square the whole shebang. Okay, so we square everything. Here we go, even the numbers. So that's going to be 9x squared over 16 y to the 16. Never square an exponent. Never square an exponent. Guys, you just told me when you had 2 exponents, what did you tell me to do with these? You said multiply them, right? Multiply them. So I have 2 exponents. I have an 8 and a 2. What am I going to do? Multiply them. If that bothers you in any way, shape, or form, stop and think. You have y to the 8 times another y to the 8. How many y's are up here on the board? 16. That's 16 y's. 2 y to the 8's. 16. So, there's our answer. All right, let's flip it over. What do you think when you look at this problem? What pops into your head? Flip. Step 1. Flip. Flip comes first. Flip first. If there's a flip, do it first. So this is going to become 1/8 to the 2/3. Instead of 8 over 1, it's 1 over 8. What's the next thing that pops into your head? Radical. Fractional exponent means radical. This radical will be a cube root squared.
Yep.
And it's 1/8. Cube root of 1.
1.
Cube root of 8. Square it. 1 squared is 1. 2 squared is 4. There's your answer, 1/4. Now, did any step there, did that go too fast for anybody? Anything confusing? Okay, Okay, so if we have a negative exponent, we take care of that first. Flip it first. And then do whatever else needs to be done. All right, 7, easy problem. What's 7 say?
110.
Not 110. 5 to the negative second equals x,
Oh, you're talking about that.
1 over 25.
right?
Oh, 1 over
So that's
25,
going to be
yeah.
1/5 squared. Flip it, flip it, flip it. And that's 1/25.
Yeah.
8 is just to see who's paying attention.
9.
The answer is 9. When you have anything of this form where these two numbers match, the answer is the leftover number. Okay? 9. Okay, this is the opposite of what we did. Oh, shoot, is it the same problem? Kind of. Oh, well. It's the opposite of what we did before. We now want to pull it apart. There's 2 letters, so we're going to have 2 logarithms. We're going to have a log of x and we're going to have a log of y.
Oh.
Because there's 2 letters. Every letter is going to get its own logarithm, okay? Pulling it apart.
You're gonna put the 2 in front of the x.
The 2's got to come out here, right? Remember we talked about that just a few minutes ago. An exponent becomes a coefficient,
Minus, minus.
and then that's going to be a minus because that is a division.
And then, wait, do you multiply it all by the log of 3?
No, that's the base on the logarithm. That doesn't have anything to do with anything. That's the base of the logarithm. That could be a 7, and it wouldn't change anything about the problem except those would be 7s. Is that okay with everyone? Exponents are coefficients, subtraction or divisions are subtractions. Oh, now we're solving this. We're going to do a few more of these today. So this is a little unfair that it's showing up on a quiz, but we're going to practice again. So I know I said to you the last time we were together that you can't solve a logarithmic equation if there's more than one logarithm on each side. So the first thing that you have to do is condense these into one logarithm. Now this is okay, there's only one over here, so that's fine. But these two have to be condensed into one logarithm. Now, it's an addition. When you put together an addition, it becomes a
8x.
multiplication. So I'm going to multiply those and it's going to be 8 times x. When you put together an addition, it becomes a multiplication. Now this is the part, I don't think we looked at one like this the other day. We'll do some more in our notes today. But I think common sense would tell you what to do next. If the log of 8x is the same as the log of 5, then doesn't 8x have to equal 5? Doesn't that just make sense?
Oh.
If the log of this is exactly the same as the log of this, then aren't these the same? So x equals 5x. We'll do some more of those in just a couple minutes. All right, how about 11? What are you thinking about this problem? We did several of these last time. What do we do first? Divide by 3.
3.
I keep telling you guys, you gotta get rid of the extra number. When you solve an exponential, you've got to get rid of the extra number. So 2 to the x minus 3 equals 16. What's special about 16?
Power of 2.
It's a power of 2. Which power of 2 is it? 4 power of 2. And again, if you don't have that memorized, you really should. But if you don't, you can figure it out. 2 times 2 times 2 times 2, 4 of them, makes 16. So if 2 to the x minus 3 is the same as 2 to the 4th, x minus 3 equals 4, and x must be 7. So really, the principle behind, at this point in this problem, we had a log base 3 of something equals a log base 3 of something, and virtually we ignored those and said 8x equals 5. Same exact thing here. When we had 2 to a power equals 2 to a power, we ignored those and said the powers are equal. It's the same concept. And one more. Anything bother you about this problem?
Yeah, all of it.
All of it? We got 2 logarithms on this side. Can't ever do that. I can't do that. No one can do that. You can't do it with 2 logarithms. You just got to put that together into one logarithm. Okay, I'm not worried about that side. It doesn't have a logarithm. I'm very worried about this. I can't have 2 over there. So I got to put them together. Okay?
Yep.
Now, how are they going to go together? Well, first of all, what do I do with that?
Put it over the 3.
That's an exponent. So that's really a 9. 3 squared.
Yep.
Should be 9 over x.
And that's a minus. So Emma says this is 9 over x. Is she right?
Yes.
That's how they're going to go together. They're going to go together as a division, and it's going to be 9 divided by x. Okay? Now we're going to loop-de-loop. That's what we do. When we have one logarithm, we loop-de-loop it. So 5 to the second equals 9 over x.
Yep.
25 equals 9 over x. I'm not going to freak out. I'm going to multiply both sides by x. And then divide by 25. So the answer is 9/25. Okie dokie. All right, well, like I said, what's the plan? I don't see you tomorrow, unfortunately, but I'll see you Monday. And Brooke's smiling. In fact, I'm not going to see you tomorrow, Brooks. It's not fun.
I have no expression whatsoever.
So Monday, we will do another practice quiz just like this one. And then Tuesday, we're going to take the actual quiz. At that point, we will also be reviewing for our test, because we don't have that much more to go. So, speaking of that, we need to finish up our notes. So let's go back to the back of page 29. And we're going to practice some more logarithmic equations. These are on the quiz. We just practiced a couple of them, but we're going to practice some more because we haven't done that many. So we're going to practice a few more here. We're going to start. We're going to start with this one. Okay, so we are on the back of page 29. This is letter C. Ready? While we're here, cross out D. D I didn't plan very well, and it just gets too messy arithmetically, so just cross out D. It's not gonna hurt you not to do it. It's gonna be better for us not to do it. All right, here we go. Take a look at this equation. We've talked about this already this morning, what's wrong with it. It has two logarithms. So the first thing we're gonna do is put those together into one logarithm. These two are gonna get combined. Now, tell me how they're gonna get combined. There's no numbers out in front, so I don't need to worry about that. They're being added. So this is gonna be x squared plus 3x. How did I do that? I times these two things together. Now, that's a 10. So to solve this, I have to get rid of that logarithm now, and so I'll loop-de-loo it. So 10 to the first equals x squared plus 3x. What kind of equation is that?
Quadratic.
It's a quadratic. So I'm going to get it set equal to 0. What do you think about that thing?
X minus 5x plus 2.
Factor it. So my answers are -5 or +2.
It's, yeah, it's x minus 5x plus 2. Isn't it?
Is
No.
it x plus 5, x minus 2?
Oh, yeah.
So then when I solve, I get -5 and +2. Set those equal to 0 and solve them. What about -5? Can you take the logarithm of a -5?
No.
No. So that guy's extraneous, and the only answer is 2. You can't take the log. Remember, we did this on our calculators. We tried to take the log of a negative, and it came up with domain error or something like that. You can't ever have a negative number in this position. So if you come up with one, you gotta throw it out. Okay. Oh, this one's long. So now we're skipping D, we're going to E.
Do you have to FOIL them or no?
Yes, you do. I don't know if you heard Olivia, but she said, do you have to FOIL that? And the answer is, yeah, we do have to FOIL because we have to put these together, right? Can't have two. They have to go together. And because that's a plus, when they go together, it's going to be a times. So you're going to be timesing x plus 4 times x minus 4. So this is going to be x plus 4 times x minus 4. So yeah, that's a FOIL. What is that when you FOIL it out? X squared minus 16. Now you got just one logarithm, so now you loop-de-loop. So 5 to the second equals x squared minus 16. 25 equals x squared minus 16. X squared equals 41. So x equals plus or minus the square root of 41. Oh, the world is not whole numbers, so don't panic that we got a crazy radical. But can I put a negative number in here? Is that going to be okay? No way. Because if I put in a negative number and subtract 4, won't that be negative? So the answer is just the positive root. I'm gonna say something here that's gonna probably confuse some of you, but some of you are gonna get this, and it's an important fact. If I had solved the equation and got x equals 3 as an answer, that would also be an extraneous root. Just because you're negative isn't what makes you extraneous. You can be positive and be extraneous. What happens when I put 3 in right here? What is this? If I put 3 in there, it's a negative. That quantity cannot be negative. Okay? Now, if that had been a plus, and I got -2 as an answer, -2 would be fine. Because when I put it in here, that quantity is still positive. The point is, that has to be positive. Whatever x you put in can be positive or negative, it doesn't matter. The quantity has to be positive. Okay? So I don't want you to get in the habit of just crossing out every negative answer, because they're not all extraneous. A lot of them are, but they're not all extraneous. Okay, one of these is on our quiz. We looked at one of these. Which side of the equation are we concerned about?
The left.
Left. What's wrong with the left side?
Because there's
Two logarithms. Can't have it. Gotta put them together. So whatever it is, you're gonna have to put them together into one. Olivia?
Is there possible to get like a no solution or something?
Yep, it is definitely possible. I don't think we will in this problem, but maybe. Let's wait, let's see what happens here. Oh, actually, we might in this problem. Because these are gonna go together, and what are they gonna, what's gonna happen?
4x.
4x. They're gonna be times, because that's an add. This is a different situation than this. Look, kids, in the last problem, when we put them together, this is what we had. In this problem, when we put them together, this is what we have. What's different? Got a log on both sides. When you only have a log on one side, you're gonna have to loop-de-loop. But if you have a log on both sides, look at that. What makes sense? 4x equals x minus 1. So 3, this is what Olivia was talking about. Good job, Olivia. Did you get -1/3?
Mm-hmm.
And when you come up here, can you put a -1/3 right in there?
No.
No, you can't. So this has no solutions. Very good. Very, very good. Okay, so take a look at it. Now we've done a couple of these now. What are you thinking, James Wayne, when you look at this problem? This is G.
It's gonna bring it down, bring like log, combine 2x and 3, and then equal it to log 7.
Exactly. So these are going to go together, and they are going to become what when I put them together?
2x over 3.
Is it going to be 6x? No, because I'm not going to multiply them. What am I going to do to them? Emma. We're going to divide them, right? Now, Monica, is this going to be a loop-de-loop problem, or is this going to be some other kind of problem? Exactly. So 2x equals 15 and x equals 15 halves. Can I keep 15 halves as my answer? Yep. Doesn't cause me any issues, so we're good. And oh my gosh, there's one more, and then we're going to start our word problems. Yay! All right, so what do you think about this last problem here? By the way, does the base on the logarithm really have anything to do with how we do the problem?
No.
No.
Over S equals.
So we're gonna put together these two. Right? We're gonna put them together.
Yeah.
We'll put them together as a 3x or a 3 over x.
3 over X.
3 over x. Those are our only two options. When you put them together, you're either going to multiply them or divide them. Don't do anything else.
3 over x equals 12.
So 3 over x equals 12.
And you get 1/4.
I am not going to panic. I'm going to multiply both sides by x and divide by 12. Reduce my fraction. X equals 1/4. Okay, we did a couple of those on the quiz and now we've done several more. So we'll practice those again on Monday and then our quiz is Tuesday, right? Okie dokie, Smokies. Now we're going to do some word problems. Word problems, these are really fun and interesting. They're real life application. Before we start though, I need to make you aware of two formulas that you need to know. So I need you to write these down somewhere. We have what's called the Pert Formula. Pert. And then we have another one. Now, I don't know if you used these formulas last year or not. It doesn't really matter. After you've done a few problems, you're going to find you already have them memorized. We're going to go through, first of all, before we start the problems, we're going to talk about when we use which formula. These are the only two I'm making you memorize. There are zillions of financial formulas. We're only going to memorize these two. I'm going to go through and we're going to talk about what each letter stands for so that you know what to plug in where to solve the problem. Okay? This formula is called the continuous growth formula. So this formula is going to be used in any type of problem where the word continuous is mentioned. So for example, you deposit your money in a bank where interest is 2.3% compounded continuously. That would be your formula. So if the word continuous is there, that's the formula. It is also the formula you're going to use for any kind of natural or nature type problem. So a population growth, that's nature, that's life. Radioactive decay, that's nature. So population growth, radioactive decay, those are the two big kinds of nature problems that we're going to be examining. Okay? So if the problem is about a bacteria population, right here. If the problem is about money being compounded continuously, right here. If it's about an element and its half-life, it's here. Okay? This is the formula. This is the formula that is used in only one situation, and that is compound interest. Most of you have savings accounts. Hopefully you all have savings accounts. And your money is compounded quarterly, or compounded monthly, or compounded daily. Any compound interest except that word, any compound interest, daily, hourly, monthly, yearly, this is your formula. So when a problem says something about, Susie deposited $100, 4% compounded quarterly, that's your formula. Okay, so you think you know which formula to use when? Okay, now let's talk about what all the letters mean. In this formula, A is the end amount. So in other words, it's how many people you end up with, how much money you end up with, how much radioactive element you end up with. This is the end amount. This is the starting amount. In a money problem, the starting amount of money is called the principal. That's why it's a P. You may see this formula with a different letter. Doesn't matter. Whatever that extra number is there in front, that's your initial value. Doesn't that make sense? A times B to the X, that's A. That's your beginning amount, your initial amount. E is Euler's constant. We already talked about that. The base of the natural logarithms. So E is E. It's not a variable. E is the number E. You have a button on your calculator for that. R is your growth constant. In a money problem, your growth constant would be the interest rate. So if your money is growing at 2%, it would be 0.02. And T is the time. In this formula, time can be in any unit. So, for example, the other day when I wasn't feeling well, I think I ate something bad, and the little nasty bacteria were growing in my tummy, and they were growing really, really fast. So their growth constant was probably measured in hours. So T would be in hours. In a radioactive decay problem, if you have a very stable element, T might be measured in decades or centuries. All right, this formula, A, same thing, this is your end amount. P, same thing, this is your start amount. So that's easy, no confusion there. That is the number 1. So that's not a variable, it's nothing weird, it's 1, the number 1. R is your interest rate. Remember, this equation only goes with money. So R is always going to be the interest rate. T is always going to be the number of years. The number of years. And N, there's 2 of them, and they are the same number. If you have the same variable in a formula, it represents the same thing. It doesn't mean 2 different things. So whatever I put here, I'm going to put here. N is the number of times per year that we compound. Remember, this formula is compound interest. So if your problem were compounding quarterly, then N would be 4. Compounded monthly, N would be 12. Got it? Okay, anybody have any questions about this? Because I'm going to be erasing all this so we can actually do a problem. All right, here we go. Number 1. How long will it take for an investment of $1,000 to double if the bank pays 2.5% interest compounded quarterly? So first thing you decide is which formula are you using. Compounded quarterly is your clue right here. So we're using the formula for compound interest. So let's write down the formula. First thing, right there in that space, write down the formula. Now let's plug in everything we know. Okay? So tell me some stuff that we know. The R value is what?
2.5.
It's 0.025. Remember, it's a percentage. And when you use a percentage in an equation, you always have to put it in its decimal form. Okay?
Is the bottom part of it and 2?
So, what's this?
4.
4. How do we know that's 4, people? Quarterly. N is the number of times a year you compound. Compounded quarterly means 4. Now, do I know anything else?
You're gonna double.
I
so you
know
wanna
P
switch
is 1,000, and yes, Emma, if P is 1,000, what is A?
2,000.
2,000. You're doubling, people. They don't have to tell you how much it is. You know double 1,000 is going to be 2,000. And the only thing I don't know is the T, which is what the question is, right? How long? What a disastrous mess that equation is. We have to solve that.
Divide by 9.
Yes. What have I been harping on over and over? If there's an extra number, get rid of it. So we're going to divide by 1,000. Oh, what now? Okay, I'm okay with doing that as long as I don't have to round it off.
Oh, we use our calculator on that.
Oh, yes. Yes. So let's see if I have to round that off. Actually, I don't. So if you are more comfortable, you can go ahead. This is 1.00625 to the 14th power. So if you want to go ahead and divide that out, you can. I never want you to round off, but if you can do it without rounding off, it's fine.
And then
This looks different, but the other day we did a problem like this. How did we do that problem?
force log.
We took the logarithm of both sides. We took the logarithm of both sides. So what I want you to do is take the logarithm of both sides of this equation. Now, the reason that you did that is because what happens to this exponent now?
It'll go down.
It comes out in front, it comes down. Now, what are you trying to figure out? You're trying to find t, right? So if we want to have t, we're going to have to divide by something. We're going to have to divide by the 4, right? And we're going to have to divide by the log. You agree? Now, we're going to go to the calculator, we're going to type it in. Red flag, red flag, red flag. When you have two, you divided by two things, right? When you divide by two things, you've got to have it in parentheses or you won't get the right answer. So make sure that you are closing all your parentheses and all that stuff. Let's type it in. Let's make sure we can. I got 27.8 years. That's not what you got? No. Okay, well, you're wrong, for sure. I know you're wrong. Now, I could be wrong too, so let me try this again, make sure. I'd like somebody to match me.
You said I include the 4 in the parentheses
Mm-hmm.
and do the division all at 1 step as well.
I
Well,
got
I did.
Yeah, that's what
And
I
I
got.
just did it again and got 27.8, so I think I'm right,
I matched.
27.8 years,
Yeah.
James Wayne matches. So, remember to close this parentheses before you do the division, and then all that's in parentheses. Got it? So how long does it take to double your money at 2.5%? 27.8 years. Okay? By the way, would I have gotten a different answer if I would have started with $10? No. No. Because if I start with $10,
It still takes 27.8 years to double.
then that would be 20, and when I divide, won't I still get 2? So the starting amount really is irrelevant. If you want to double your money at this interest rate, it's going to take 27 years to double whatever you start with. Okay? All right, let's do the next one. How much will be in the account at the end of 10 years if $1,230 is invested at 3.125% interest compounded monthly? Same formula. Everybody good with that? Same formula? Clue is compounded monthly. I don't think we're finding T again. We're finding A, aren't we? How much are we going to end up with if we start with 1230? The interest rate is 0.03125 over 12. And what's my exponent going to be? 12 times 10? Because it says 10 years. So 12 times 10 is 120, so I'm just going to do that real quick. You don't need logarithms for this problem, guys. The only time we need logarithms is when our variable is up here. That's the only time we need logarithms.
So you just multiply it out?
You just multiply it out. And you can just type that in exactly the way I wrote it. If you put the parentheses exactly where I put them and use your little caret button, you're going to get the right answer. So 1230 parentheses 1 plus 0.03125 divided by 12 close parentheses raised to the 120th power. I got 1680.53. Tell me if you match that. Shooty tooty, is time up already? All right, we all eventually showed up except Jalen, Matt, and Johnny, right? Okay, well, you have the game plan, you know what's happening. I got any Friday hugs today.
Oh, yeah.